All right, this is section 7.3. It has to do with multiplying polynomials. It has to do with factoring polynomials. And that's what we're going to cover today. Multiplying polynomials together. We're going to be factoring some polynomials. I know we did some factoring before, but we're going to extend that a little bit. And we're also going to, tomorrow, we're going to cover the second half that has to do with dividing polynomials by using long division and by using something called synthetic division. I know some people are going to be gone tomorrow with DECA, so I'm going to encourage you to check the website. If there's somebody that does not have access to a computer, let me know. But it's crucial that you have to check the website and get your notes. All right? Questions?
The factoring is talking about is where you have the polynomial under the bracket.
Yes. Long division, right. Yeah, we'll do that tomorrow. I hate to save a hard topic for Friday, but that's just the way it's going to work out. So, all right. So, first thing I want to talk about today is multiplying polynomials. Okay. And the first type, I'm going to multiply a monomial times a polynomial. So let's take 3x squared and multiply it by 2x minus 5x cubed plus 4x squared minus 2x to the fourth minus 6 plus x. All right. And so if I had to multiply that together and then put our answers into standard form, all we're really doing is we're distributing. And when I multiply 3x squared times 2x, the result is going to be what? 6x cubed. We're adding exponents now. And then I have minus 15x to the fifth, because we add the exponents. And then 3x squared times 4x squared will give me 12x to the fourth, adding the exponents. And then I have negative 6x to the sixth, negative 18x squared, plus 3x cubed. I combine like terms if there are any, and I can see in the first and last term, I have 6x cubed and 3x cubed. That'll give me 9x cubed. Well, let's put this in standard form. So we'll put the highest exponent first, 6x to the sixth, minus 15x to the fifth, plus 12x to the fourth, and then 6x cubed plus a 3x cubed at the end will give me 9x cubed, and then minus 18x squared. All right, so I don't think that's going to be too big of a deal there. But let me ask you a question here. Can you describe the end behavior of this polynomial? Come on, Summer, you can do it.
It goes down and then it goes down.
Okay, so it falls on the left. That's the way we say it. It falls on the left and falls on the right. Remember, when we have a leading exponent here that is an even exponent, and both ends are the same. And because we have a negative, they both fall. So falls on the left, falls on the right. We don't know what happens in between the two endpoints. We don't really care at this point. But right now, I do know what the end behaviors are. Question?
If it was odd, how would you tell which one to fall?
Okay. If it were odd, let's say we have something that's negative 5x to the 7th minus, and a bunch of other things, okay? That means that one end is down, the other end is up. Which is which? If you were to graph something like y equals x cubed, the parent function, we have an S-shaped curve. Okay? And because the x cubed is an odd exponent, it would fall at the left and rise at the right, correct? Okay. Well, that's the same if it has an odd exponent of 7. But since it's negative, it's going to rise on the left, fall on the right. Okay? All right. So that's one example of multiplication we're going to be doing. Another example, let's say I have 2x plus 3. Now I'm not going to go over multiplying binomials together using FOIL. I think everybody knows how to do that. So if I had 2x plus 3 times 3x minus 2 quantity squared. Okay, what would we do first?
You would square the 3x.
You would square the 3x minus 2 first. Exactly. Okay. All right, so we have 2x plus 3 times. What does that equal? Go ahead.
9x squared.
9x squared
Minus
minus 12x is correct.
plus 4.
Plus 4, perfect. We use that, and what Kurt just did is use that three-step process to square a binomial, where we square the first term to get 9x squared. We multiply the two terms together to get 6x, and then we double it. That's where you get the negative 12x. And then we square the last term to get to 4. All right? Now, can you multiply a binomial times a trinomial? Do we know how to do that? What do you think, Olivia?
I think you do 2x times everything in it.
2x, perfect. 2x times everything, and then 3 times everything. So 2x times 9x squared will give me 18x cubed. 2x times negative 12x is negative 24x squared. And 2x times 4 is 8x. And then I have 3 times 9x squared. That'll give me 27x squared. 3 times negative 12x, negative 36x. And 3 times 4, which is 12. Combining like terms, 18x cubed. I have negative 24x squared plus 27x squared gives me a positive 3x squared. I have 8x minus 36x will give me negative 28x, and then plus 12 at the end. All right. The trick is going to be for us to go from this polynomial back to where we started from. And that's where this chapter is going. How can we factor that? I can sketch this drawing based on our knowledge, and you can too. Okay? First of all, describe the end behavior. Read.
Falls on the left, rises on the right.
It's going to fall on the left and rise on the right. Odd exponent. Okay, very good. Can you tell me what the zeros are? What is across the x-axis? Look at the original problem up top. It's going to cross negative 3 halves and at 2/3. So this is going to be 2/3 over here. This is negative 3 halves. But there should be 3 zeros. Where's the other one? Well, here's what's going to happen here. We know it falls here. So it's going to come up. It's going to come down, but it's not going to cross because then it can't come back up. So it's going to touch. And that's what it looks like. Okay. And the reason why it touches is because of 3x minus 2 quantity squared. When you see something like that, it just touches the x-axis and then goes right back up. And there's my S-shaped curve. I don't know how high it goes. Well, actually I do. That right there, that point is 12. Because when x is 0, y would be 12. So we can draw a fairly accurate sketch if I had a real grid up here rather than just sketching it. But we won't have to do that just yet. We're just multiplying these polynomials together. All right. Let's take 2x plus 5 and cube. Now there is a formula for cubing a binomial. But I think it's just as easy to do it out longhand because when these binomials get a little bit more involved, and to try to put that into the formula can be a little bit confusing. And we'll get to that, but maybe a little bit later in the course. But I think the best way to handle that would be to write 2x plus 5 quantity squared times 2x plus 5. Right? So I think if we do it out this way, I think it's going to be a lot easier for us. Squaring the first parenthesis, we square the first term, multiply the two terms together, which is 10x, and double it, and square the last. And then I'm going to multiply that by 2x plus 5. And we do the same thing that we did for the other one. Like Olivia said, we just distribute. So 4x squared times 2x would be 8x cubed, and 4x times 5 would give me 20x squared. 20x times 2 would give me 40x squared. 20x times 5 would give me 100x. And 25 times 2x is 50x. And 25 times 5 would give me the 125. And then we simply combine like terms. 8x cubed. I have 20x squared plus 40x squared would give me 60x squared plus 150x plus the 125. Okay? And again, we have a cubic polynomial. Falls on the left, rises on the right. What are my zeros? -5/2. And it's just going to touch. That means at -5/2, actually there's an odd exponent, so it is going to cross it. And it could take a little dip here, I suppose. It'd be something like that. And it's an odd exponent, and that's why it crosses. If it were an even exponent, it would just touch and go back down. Okay? All right, multiplying polynomials. And that's what we're going to do on page 445. So we're going to do the problems 14 through 33. If they give you the problem in fractions, put fractions in your answers. All right. So now we talk about factoring. Factoring. The first thing I want you to look for when you factor, well, maybe we have something like this. 5x cubed minus 500x. All right, 5x cubed minus 500x. And I ask you to factor it. The first thing I want you to look for is, do either one of those terms have a common factor? And what did you see? You saw 5. What else?
5x.
5x. So let's take out, by the distributive property, we'll take out a 5x. The result is going to be x squared minus 100. Anytime you factor, this is important, anytime you factor, you're going to look at all the terms and see if there's anything that they have in common. And we factor that out first. Then we look in the parenthesis and see if we can factor it further. And Kirk, you already saw something, didn't you? What did you say?
It's 5x then times x minus 10, or x.
You're right.
X minus 10, and then also times x, or plus 10.
Plus 10, right. We see that in the parentheses, it's the difference of two squares. And so it becomes 5x times x minus 10 and x plus 10. My zeros are 10, negative 10, and 0. Those are the three places where it crosses the x-axis. Negative 10, 0, and positive 10. And you can see where we get an S-shaped curve. Here's negative 10, and of course the origin, and there's positive 10. And we don't have to graph. But what we're after here, and the reason why we factor is to find the zeros, find the roots. Sometimes they're real, like this case. Sometimes they're imaginary. When you get to calculus, will show you how to find the area under the curves. We'll show you how to find tangent lines, and a lot of other good stuff. And that's the next step. But the factoring part is extremely important. Know how to work with these polynomials. All right. So we can factor the difference of two perfect squares. Maybe we'll get a problem that looks like this, and I'll tell you to factor it. X cubed minus x, well, let's go minus 2x squared minus 9x plus 18. I got four terms there. Do you remember how to factor if it has more than three terms? What method we use? Yeah, grouping. So let's group. If you have more than three terms, we factor by grouping. I'm going to group the first two terms together. And then I'm going to group the second two terms together. Mark 9x. And what goes in the parentheses? Right. What goes in the parentheses? Anybody? Hunter? Negative 18. And that's good because you got to remember when you put a parenthesis in back of that negative, we have to change the sign from a plus to a minus. Very good. Now let's take out common factors. In the first parenthesis, we can take out an x squared, and we're left with x minus 2. In the second parenthesis, we can take out a 9, and we're left with x minus 2. Notice I have two common factors here of x minus 2. It is still not factored. So it is x squared minus 9 times the common factor of x minus 2. And can we factor further? Yes. Because you look at that first parenthesis, and that's the difference of two squares, isn't it? So I can factor this as x minus 3, x plus 3, and x minus 2. So I want to look to factor completely. Michelle.
Do you only switch the sign in the second step if it's a minus?
That is correct. You only switch a sign in the second parenthesis if you put a parenthesis by a negative. If that were plus 9x, you wouldn't have to do that. Hunter. Go ahead.
But it deals with this. If you were to have 5 in your polynomial equation, would you just group 1 with 3 and group 1 with 2?
That's a good question. Yes, you would. And that gets a little bit involved, and I don't know, you won't have anything like that in your homework. Sometimes you'll have 6 terms where you have to group 3 and 3, and it gets a little bit crazy. But okay, so we've multiplied polynomials together by a variety of methods. We factored by looking for a common factor. We have the guess and check method if we need it. Then we factored the difference of 2 squares, and then we factored by grouping. Can we factor the sum of 2 squares? Like x squared plus 9? Does that factor? No. We have nothing to factor x squared plus 9 over the real numbers. Okay? However, we can factor the sum of 2 cubes. We can factor the sum of 2 cubes. And there's a formula that goes along with it that you're going to need to memorize. And this says it is a plus b times a squared minus ab plus b squared. That is the general formula for factoring the sum of 2 cubes. Okay, and let me show you how this works. X cubed plus 8. X cubed is a perfect cube. 8 is a perfect cube. Right? So let's just fill in the numbers here. The cube root of x cubed is x. The cube root of 8 is 2. Okay? Now the rest, you're just following the pattern in the second parenthesis that says you square the first term, so that's x squared. Don't change any signs. The signs are built into the formula. Minus a times b, 2 times x. And then plus the b term squared, which is 4. If you know that formula, you should be able just to put things right into the place. By the way, this second parenthesis here does not factor, ever. You do not factor that. You can't factor any further than what it is. Let's try another problem. 27x cubed plus, well, let's try 125. I already know in my formula I'm going to have a plus there, and then I'm going to have a minus and a plus, and those signs are built in. What is the cube root of 27x cubed? 3x. And the cube root of 125? 5. Then we square the first term, according to my formula up there. I'll get 9x squared. Multiply the 2 together. 5 times 3x is 15x. And then we square the 5. Okay. Once you know that formula, memorize the formula. Students have trouble memorizing. Okay, but once you do, it becomes easy. Okay. All right, one more example. We can factor the sum of 2 cubes. We can also factor the difference of 2 cubes. I can also factor a cubed minus b cubed. The formula is similar. it is a minus b times a squared plus ab plus b squared. And we'll see how that works. We'll do x cubed minus 8 this time. And you're going to find it's the same numbers because the formula is the same. The only thing that changes are the signs. Instead of a plus b, instead of x plus 2, it's going to be x minus 2. And then we have x squared multiply 2 together, 2x, and then plus 4. Okay, that makes sense? And then if I have 27x cubed minus the 125, for my signs, look at the original formula up here. I'm going to have a minus, and then a plus and a plus. And those signs are built into the formula. I have 3x and 5, 9x squared, 15x, and 25. And I know it seems easy when I do it, and that's because I've memorized the formula. Once you memorize that formula and start to do a couple, it should go pretty smooth for you. Hunter? Okay. The homework is on page 445 to 447. And like I said, this is a 2-day assignment. But for tonight, I want you to do problems 14 through 60. And I want to make sure that you have that completed before you come to class on Friday. All right? And then I'm going to show you a couple other things tomorrow with long division and synthetic division. And then we'll continue and we'll do problems 61 through 102. And this entire assignment is going to be due on Monday. Okay? So we have about 20 minutes left in this class. Try to get as much as you can done from the 14 through 60. And make sure you complete it all before you get to class tomorrow. Okay?